Hey guys, welcome to lesson 7. We're going to talk about special right triangles. For some students, this is a real struggle for them. It's really just about side ratios. The ratios never change, whether it's 45, 45, 90, or 30, 60, 90. In a traditional geometry class, you would go from here directly into right triangle trig, where you introduce sine, cosine, and tangent. And this plays a part in that. In K6, you most likely will not, or K8, you most likely will not get too deep into this. But I would encourage you to not avoid it if it comes up. I think that this has a lot of practical applications, especially like if somebody wants to go build a house, whatever. A lot of times, contractors, carpenters, whatever, will use the 3, 4, 5 triangle to see are they actually doing a right corner. Is the corner actually right? They'll use a 3, 4, 5 triangle, 3 feet one way, 4 feet the other way, and 5 feet on the hypotenuse to see if it's a triple. All right, this is again one of my favorite topics to talk about because it's like a puzzle, and so well. With all of that, let's go ahead and get into it. All right, so there's two types of special right triangles, the 45, 45, 90 and the 30, 60, 90. Each of these has a consistent side ratio that that if you know it will keep you from having to do the Pythagorean theorem so much. And so you can actually go ahead and prove with your students how these ratios come about using the Pythagorean theorem. And maybe that's helpful, especially with some of the students struggling, because sometimes students, they want to know the why behind things, which is not a wrong thing to do, but at the same time, sometimes they throw that out, why are we learning this question? They just throw it out there to get you off track or whatever. And so you can, or where does that come from? Sometimes they ask that question, like you can go ahead and prove it. And so I would have the proof in my back pocket and bring it out if necessary. But if you plan to study trig, the special right triangles play a big part in that. So the side ratios for 45, 45, 90 is x squared of 2. All right, and with the 45, 45, 90, because these two angles are equal, this is an isosceles triangle, which is why those sides are like that. So you got x and x squared of 2. Now, with the 30, 60, 90, the sides are not the same. One shorter than the other. But the hypotenuse is always the biggest side. The shortest side is across from 30. The longer leg is across from 60. And then, of course, the hypotenuse is across from the right angle. All right, so across from 30, you're going to have x. The hypotenuse is going to be 2x. And then the longer leg is going to be x squared of 3. So you have x squared of 3, and 2x. Those are your ratios. Okay, so let's get after it here. So on number 1, all right, if you look at the ratio, this is a 45, 45, 90. All right, so the side that's supposed to have a square root of 2 doesn't. So how do you deal with that? Well, you just do a simple calculation. Because x is one of your sides, I would pick another letter here and say, so the a square root of 2 is 28, and then you just divide. So a equals 28 divided by square root of 2. Well, if you remember, you can't leave a radical on the bottom. So you have square root of 2 over square root of 2, and you multiply. So this is going to give you 28 square root of 2 over 2, and that reduces to 14 square root of 2. All right, so that tells you what the sides are. So both of these sides, x and y, are both going to be 14 radical 2. All right, and here you go. All right, on 2, 16 is your 2x side. All right, so if this is 2x, this would be, if this is 60, that means this is 30. All right, that means this is going to be your x side, and this is going to be your x cubed root of 3. Again, you might want to pick a different letter because x is one of your sides, but this tells you that y is 2, and this is going to be 2, not 2. This is going to be 8, and this is going to be 8 squared root of 3. So if you if you really lock down on these ratios, this gets really simple. All right, so like number 3, this is an isosceles 45, 45, 90. The one leg is 4, so that means this is 4, and this is 4 square root of 2. All right, it's kind of like riding a bike. At some point, you no longer think about it. It's just second nature to you. All right, for number 4, 6 is across from 60. That's supposed to be the square root of 3 side. So just like number 1, I'm going to say a square root of 3 equals 6. Okay, so that's going to be a 6 square root of 3, or 6 over square root of 3. You rationalize it. So square root of 3 over square root of 3. All right, so that's going to give you 6 square root of 3 over 3, which is 2 square root of 3. All right, so that's going to give you 2 square root of 3 right here. And then you multiply that by 2, and you get 4 square root of 3 right there. All right, 5. Starting with number 5, we started to get into these more complex triangles. All right, so you just kind of want to piece it together with what you know. I know this side is 9, so this must be 18 right here, which would be, this is 9 square root of 3. All right, then you do your little calculation here. A square root of 2 equals 9 square root of 3. So you divide, you get 9 square root of 3 over square root of 2. And then after you do the rationalization process a few times, that becomes second nature. And this is going to give you 9 square root of 6 over 2. All right, and there's nothing else I can do. So 9 square root of 6 over 2 is both x and y. All right, on 6. All right, 60 is across on the other side. So your shorter leg is 7 square root of 3. So that means your x is going to be 14 square root of 3. And then when you multiply 7 square root of 3 times square root of 3, you end up with 7 times 3, which is just 21. So this side right here is going to be 21. Okay, and since this is also 30, now the 21 is across from 30, which means that's the short leg, which means this is going to be 42, and this is going to be 21 square root of 3. Okay. 7. Let's see. You got 15 square root of 2, which means this is going to be 15 right here. This is going to be 15 right here. All right. The 15, you got a square root of 3 equals 15. So a equals 15 square root of 3 over 3, which is going to be 5 square root of 3. So you got 5 square root of 3 right here. And you multiply that by 2, you get 10 square root of 3. Right? So on 8, you have a square root of 3 equals 18. And then you have, that's going to be 18 square root of 3 over 3. So it's going to give you 6 square root of 3. All right, so that means that z is 6 square root of 3. This hypotenuse is going to be 12 square root of 3 because you multiply it by 2. All right, and then you have, let's see, b square root of 2 equals 12 square root of 3. Okay, so b equals 12 square root of 6 over 2, which is going to be 6 square root of 6. All right, which means x and y are both 6 square root of 6. All right, so that's a quick review of special right triangles. Again, I would not avoid this lesson. I would really practice it if you get to it. So I hope you got something out of that, and I will see you in the next lesson.